Okay, so this one look at inverse trig functions and looking at the domain and range. So we'll just look at y equals sine the minus 1x. So its domain is in between minus 1 and 1, and it's actually equal to it. And its range is in between minus pi on 2 and pi on 2. And it is equal to it. Okay, and it looks a little bit like a cubic shape. It is an odd function. That's why sine the minus 1 of minus x will equal minus sine the minus 1 of x. Okay, so that's the sine the minus 1 function. Let's look at the cos the minus 1 function. So the cos the minus 1 function starts at the top here because cos is negative when it's at pi. So it's like minus 1, so it comes back like that and comes down, and that's 1. Okay, so that's the cos the minus 1 function. So the domain is in between minus 1 and 1, and the range is in between 0 and pi. And the tan the minus 1 function, so the tan the minus 1 function, we go like this, and here, this is pi on 2 and minus pi on 2. So it's almost like a cubic on the side, or the normal tan function, but it's flipped over because basically it's reflected in the line y equals x. So the domain of this one will be minus infinity to infinity, or like all real x, and the range would be between minus pi on 2 and pi on 2. So when you're looking at the domain and range and you want to sketch it and you've got additional numbers in your graph like that, then the best thing to do is you start with the domain, and you know that the normal domain is in between minus 1 and 1. So if you take the x minus 3 of what's there and you put it in between minus 1 and 1, and then you solve it, you see that if you times by 3, it'll be between minus 3 and 3. The other way of looking at it is the normal one goes in between 1 and minus 1. And when you're inside the function, remember the dilation, it'll be opposite. So it'll be times 3 because that is divided by 3. So that's why it's between minus 3 and 3. So you could just use your function shifting stuff as well. So the range, you see the y value is 3 times as big. So normally it's in between minus pi on 2 and pi on 2. So if you times that by 3, then it becomes minus 3 pi on 2 and 3 pi on 2. So 3 minus 3, 3 pi on 2 and minus 3 pi on 2. So it's a sine function, so it starts there, it's like a bit like the cubic, and that's what your graph would look like. Okay, if you said y equals 4, and we go cos the minus 1, and we'll go 2x on 5. Okay, so the domain of that one, so if you look at it just by looking at, normally it's between 1 and minus 1, so normally it would be 1 to minus 1. Reverse operations, it would be times 5 and divided by 2. Times 5, not 3, 5. So it would be times 5 divided by 2, times 5 divided by 2. You could also look at it by placing the 2 on x on 5, and you place it between minus 1 and 1, and then you just solve that equation. So if you times by 5, it would be between minus 5 and 5. Divide by 2, it's in between minus 5 and 2 and 5 on 2. So the domain is minus 5 on 2 and 5 on 2. With the range, once again, you have a 4 there, so the range will be 4 times as big. So normally it's between 0 and pi, that's pi on 2. So all of these just get changed. So it's times 4, that will end up being 2 pi there and 0. Because if you times 0 by 4, you just get 0. So it's going to be between 0 and 4 pi. Okay, so let's look at the tan one. Let's make it a minus a half tan x minus 1 on 3. Okay. So looking at that there, the y value will be times minus a half. So what's it going to do is it's going to actually flip it in the x-axis, because the y's will go from positive y to negative y. So normally it would be like this, but instead of doing that, it's going to flip. That'll be like that. And it normally goes between pi and 2 and minus pi and 2. So now it's going to go you times a half times a half. So it ends up being between pi on 4 and minus pi on 4. Now as for the x, the timesing by 3 just dilates it, which just affects its steepness. But what actually happens to the x, if you look at the reverse operations, it's times 3, but then you also have to shift to the right 1. So that means that'll go to 1. So the new graph will look a bit more like that. So just fix that up a little bit. So it's going to go like this, and the new graph will go through 1, sitting like that, and it looks like a bit like a tan 10 function on its side, or a cubic. Okay, so let's look at 4 sine the minus 1 of x. So we'll do 2 minus x on 3. So the domain 2 minus x on 3 is normally between minus 1 and 1. When you times by 3, it will then go between minus 3, 2 minus x and 3. When you minus 2, it'll be minus 5 is minus x and 1. And then times minus 1, it'll be in between 5, and the inequality sign must change around because you're timesing by a negative. So x will be in between 5 and 1. So this whole graph, because of that negative on the x, it has flipped in the y-axis. So it's going to go from 1 to 5, so it's flipped the other way around. Halfway there would be 3, so it's going to be like that. Okay, and the y value is normally pi on 2 and minus pi on 2. This one has a 4 in front, so if you times 4, that means that that ends up being between 2 pi and minus 2 pi. So you've got the domain 1 to 5, and the range would be 2 pi minus 2 pi to 2 pi.